Continuing on with Chapter 17, Sticky Notes, we ended on page 454 with the last video, and going on, just to reiterate about inversion layers, lots of information about inversion. You'll watch some little videos to help you understand inversion as well. And it is something that affects us in Santa Clarita, so it's something important to understand, not just for the AP test. All right, going on to page 455. On 455, we talk about the Coriolis effect. So what we learned on the last page is that the rise of warm air and the fall of cool air, which we call a convection cell, this occurs mainly every 30 degrees latitude. And then we have the spin of the Earth on its axis deflects the air. This causes winds. So the Coriolis effect is both rise and fall plus the spin of the Earth. Now in this chapter, we're talking about it in terms of air, but the Coriolis effect also diverts water currents in the ocean and also any other kinds of liquid as well. All right, so in this picture, we have a couple of more pieces of information. So on the page before that, we talked about warm air rising and it's moist, it drops its rain, and it falls. It happens about every 30 degrees latitude. So we can see here at the equator, it's rising and then going north and going south. Oh, sorry, north and south, 30 degrees north latitude, 30 degrees south latitude. And it has this pattern all over the planet. So we have these every 30 degrees north and south latitude. So you need to know, actually you no longer need to know the names, so you can skip that, but you need to know how convection cells work. And we have polar cells, spiral cells, Hadley cells. Again, you don't have to know the names anymore of the cells, but you need to know that they're every 30 degrees latitude. So from 0 to 30, 30 to 60, 60 to 90 degrees latitude. And 90 is where the poles are. North Pole, South Pole. Okay, so what makes these convective cells? You need to know it's solar radiation, so the heat of the sun drives them. It causes the air to warm. It causes the air to be moist because of evaporation from bodies of water. And we have a lot of bodies of water, the ocean, lakes, etc. And global wind patterns primarily result from this intense solar radiation at the equator and the density differences and the Coriolis effect. So it's a little bit more detail than up here, okay? So warmer water creates more rain and snow. So how this applies here is that one of the reasons why we don't have a lot of rain off our coast is, well, because it's dry air. Also, our water off of our coast is cold, and colder water doesn't evaporate as much. Okay, well, let's talk about something like the Great Lakes. Well, the Great Lakes are cold, especially in the winter, but that water is warmer than the land next to it. So that warmer water in the Great Lakes is going to evaporate in the winter and turn into snow, and snow all along those areas surrounding the Great Lakes because the actual land is super cold in the winter. So places like Buffalo, New York, and Wisconsin, they get huge amounts of snow because they're right next to the Great Lake, which has warmer water than the surrounding land. All right, on 456, you also need to understand that deserts and arid climates like ours occur at 30 degrees north and south latitude and near the poles because of this convection process. 60 is usually rainy. So the poles we've talked about way back in chapter 4 when we talked about biomes. The North and South Pole biomes is the tundra. And sometimes people call it a frozen desert. It's not a desert, it's a tundra, but it has very little rain. But when it rains, it snows and ices and it sticks. And so it gets very little rain at the poles and the tundra because of convection. Same with us. So we're not quite a desert, we're chaparral, but we are arid. Arid means dry. So we have a dry, arid climate, and we're at 34 degrees north latitude. Another reason why we are so dry is because we're in a rain shadow. So what happens is that areas behind mountains are drier because as rain is formed over the ocean, it travels over land, but as it rises, it can't hold as much moisture. So it drops its moisture on this side of the mountain, and by the time it gets to the other side of the mountain, it doesn't have very much moisture at all. So we're already dry from being 34 degrees north latitude. We are drier than LA because we're behind actually 2 mountain ranges from the coast in Santa Clarita. It's one of the reasons, if you know anything about the Sierra Nevada mountains, on this side of the Sierra Mountains is Yosemite National Park, Sequoia National Park. They have a lot more rain. And then over here on the eastern side of the Sierra Mountains is Mammoth, and it's a lot drier in Mammoth than it is. Now, Mammoth gets snow, but right behind Mammoth is Death Valley National Park, which is a big old desert. And it is caused by the rain shadow effect from these mountains, the Sierra Nevada mountains. So the rain shadow is something you have to know as well. So a couple of things cause deserts, being at 30 degrees north and south latitude, and the rain shadow effect. Going on to 457. So we have natural air pollution. It's not just all man-made. So you need to know that natural fires that are not set by humans, so lightning strikes, volcanic eruption, dust storms, those can be natural air pollution. Okay, so now we're to these terms that we learned with water pollution. Point source, non-point source. So again, if you can say that pollution came from that power plant that creates electricity, that factory, then we call it point source. Non-point source is a bunch of little things together making a lot of pollution. So all of our cars together making a lot of pollution. A lot of people burning fireplace wood can create a lot of pollution. They have this problem. The worst air pollution that Alaska has. Alaska actually has terrible air in the winter because most people in Alaska burn wood in their stoves to heat their houses. So like Juneau, Alaska has terrible air in the middle of winter. And you wouldn't think Alaska would have terrible air, but they do because of fireplaces. Now we have terrible air because of cars. We have so many cars in the LA area. And then we have inversion layers too on top of that. And then with the mountains sort of trap all that air pollution too. So we have a lot of things working against us. Page 458 is the Clean Air Act provisions. You need to know all of these things that the Clean Air Act does. First, it sets standards for air quality. It sets emission limits for industry. The word emission means things that you release. So it can be water that's released, air that's released. It's an emission. So industry has limits on how much they can pollute. Transportation, our cars have limits on how much they can pollute legally. The Clean Air Act also provided funds for research on pollution. Citizens can sue violating parties. So if you live next to a factory that's polluting more than it's allowed to, you can sue them. It also has something called cap and trade pollution permits. Example for sulfur dioxide. Power plants have a cap on how much they can pollute. And then if they're under their limit, their cap, they can trade more allowances with dirtier polluters. And so that is cap and trade. All right, in this part of the chapter, we have a lot of different air pollutants that you have to know, from carbon dioxide to sulfur dioxide to nitrogen dioxide, volatile organic chemicals, particulate matter, lead, and there's actually more. These are the 6 ones monitored under the Clean Air Act, but there are other air pollutants as well. We will make a chart with all of the details. So as you're studying this chapter, you need to study that chart a lot. All right, going on. Page 460 talks about some ways that we reduce air pollutants. So in our cars, we have something called a catalytic converter, which is a picture here, and it shows how it does that. And you don't have to know all the reactions and how it does that. If you're interested in cars and you want to know, it's outlined for you here. What you have to know for our test is that it removes carbon monoxide, nitrogen dioxide, and hydrocarbons. That's what it removes. It turns these things into less harmful. Now, CO2 is for global warming, but it's not an air pollutant. Nitrogen gas, oxygen gas, and water. So that's what catalytic converters do. They change these into these. Another thing that we do in California is we have vapor recovery nozzles on our gas pumps. So there's special pumps that prevent fumes from escaping into the atmosphere. So gas fumes are VOCs, volatile organic compounds. And in your chart, you will learn that VOCs combined with NOx, nitrogen oxides, to create ground level ozone, another air pollutant. So we want to reduce the amount of VOCs emitted to reduce the amount of ozone as well. As we go through this chapter, I know this is a ton of detail and part of it may be confusing. We will do a lot with this chapter to help you understand all of these things. Page 461, some other things that we do. So we learned what we do for cars. Here's what we do for smokestacks. We put on things called wet scrubbers that remove sulfur dioxide from smokestacks. So when we burn coal, it emits sulfur dioxide, and 40% of our electricity is created from burning coal. So on coal power plants, we put these devices in called a wet scrubber that removes SO2. We can also put something called an electrostatic precipitator that removes particulate matter. There's another thing that removes particulates called a baghouse filter. And then here's something else that removes SO2, something called fluidized bed combustion. They're in boiler furnaces. So what this means is in some buildings, they burn coal to heat the building, and it's in the boiler room. So these are really cold places. We don't do this in California. So in really cold places, they burn coal for heat in their furnaces. So this fluidized bed combustion uses calcium carbonate, and the calcium carbonate actually absorbs SO2, sulfur dioxide, and turns it into a less harmful substance. And so this is what a fluidized bed combustion device is. Again, lots of details. You have to know all four of these things that remove air pollution and which air pollution it removes. From smokestacks and from buildings. On page 462, it talks about toxic air pollutants. They pose risks because a lot of the toxic air pollutants are also volatile organic compounds. There are other things as well. Heavy metal pollution like mercury and lead and things like that, they can cause cancer. So in this chapter, most of our air pollutants actually do not cause cancer. They cause like asthma and other respiratory problems, but toxic air pollutants do cause cancer. But it's not your go-to. If you can't think of what an air pollutant causes, don't write cancer. It's more likely going to be asthma. All right, we'll continue on with the next video.